My candidate for coolest science news of the year goes to this paper, which showed that we can take a tardigrade protein and put it in mice, and it will prevent radiation damage when they undergo radiation therapy. Tardigrades can survive about 1,000 times as much radiation as humans can, and a big part of the reason why is a protein that's been called damage-suppressing protein, or DSUP, which literally just binds to DNA and acts like a shield, absorbing the brunt of it instead of the DNA taking the damage. Now, the side effects of radiation therapy for head, neck, prostate, and some other cancers can be so severe that some people forego the treatment altogether after experiencing how bad the side effects are and increase their risk of dying from that cancer. So it would be really great if we could still deliver that radiation to the cancer tumors without harming the healthy cells around it and leading to these horrible side effects. Well, what this paper showed is that we are now at a level of sci-fi sophistication where we can take that damage-suppressing protein from the tardigrade, create an mRNA sequence that will produce that protein wherever it's injected, add that into the inside of a lipid nanoparticle, very similar to the kind that are used to carry around cholesterol in our own bodies, except this one has targeting proteins on the outside to ferry that mRNA sequence to the exact tissues that are about to be radiated. Once the mRNA sequences are in those target tissues that get irradiated, they get transcribed to create that damage-suppressing protein, protecting the DNA from radiation damage and from damage that occurs from hydroxyl radicals or just reactive oxygen species in general that get created from radiation therapy. In the mice, this attempt reduced double-stranded DNA breaks by 50% and did not affect the performance of the radiation therapy at killing the cancer tumors. This won't be applied in cancer clinics in the next few years, but it gives me chills to think about what we're really doing here. We identify a species that's really tolerant of radiation. We figure out why. We take that protein, reverse engineer the mRNA sequence that'll make that protein, put that in a delivery mechanism that goes to the specific site we want it to go to, and lasts just for as long as we want it to last for the radiation therapy, and then goes away. I mean, if you liked this, make sure to follow my Substack for the coolest science news.